All right, there. Without any further ado, we're going to welcome Dr. Terry Bates. Hey, Terry, how's it going?
Hey, Fritz. Happy to be here.
Awesome. Good to see you, my friend. We go back quite a ways. You're also like me, a Penn Stater. And,
Yep.
I think probably when I look back to graduate school and undergrad, there was a time where there was a nutrition professor who was highly specialized, not necessarily in grape growing, but, in world crops. I mean, he was actually solving world hunger problems. And that was Dr. Jonathan Lynch. And I know you worked with him quite a bit, but
I
man,
did. He was
um,
my major professor at Penn State.
yeah. So,
Bri-
and
yeah, brilliant guy.
absolutely. And, he worked on nutrition and a lot of other crops. And I think I'm going to have you back on another time so you can talk about nutrition, because you are highly specialized in vineyard nutrition, and not just in wine grapes, but also juice grapes, and just the differences in how nutrition is treated in those two crops, or those two types of grapes, is amazing to me. But today we were going to talk a little bit about crop estimation, because lately most of the headlines coming out of your lab are all about technology, all about efficient vineyard management.
Yep.
So maybe you can start by just telling us a little bit about yourself, and how you got interested in vineyard efficiency. We're not going to call
Okay.
it digital agriculture or precision agriculture. You tell me what you want to call it,
Yeah,
because
it's all part of it. Yeah. Great. So thanks again for having me on. I went to Penn State. I studied under Jonathan Lynch in the plant nutrition laboratory. We did a lot of work with root biology on beans. I did work on like Arabidopsis. But for 25 years, I've been working for Cornell University. I am now the director of the Cornell Lake Erie Research and Extension Lab in Western New York, where we have about 30,000 acres of vineyards in Western New York and Western Pennsylvania, which my program, that's our stakeholder group.
what I love, Terry, about what your lab is doing is you're bringing it down. We'll talk a little bit later about the app that you've created, where even a small grower could learn to apply some of these efficiencies in their vineyard. So I'm super curious about how a grower can approach that. But I'm also going to link in the show notes that video you sent me that kind of overviews what you're doing with these sensors in the lab in terms of
Yeah.
soil sensors, plant sensors, yield sensors. There's a lot going on there. I want to try and stay on topic for crop estimation today. So when it comes to crop estimation, can you walk us through how your proximal sensing, maybe tell us what proximal sensing is, as opposed to other types of sensing like satellite imagery or other types? How's that helping you advance with crop estimation? And, how's this helping all size growers? If I can throw that into as an
Wow,
addition.
that's a loaded question. Okay, so let's first let's just handle the, without getting into sensors, just about crop estimation. And you're probably going to cover this in other parts of your talk today about the different ways of doing crop estimation. I mean, there's a traditional way of, counting your yield components: shoots per vine, clusters per shoot, berries per cluster, and berry weight. And if you could spatially measure that throughout the vineyard, you'd have a really good crop estimate. The curveball that we throw in with Concord Industry is we will go out at 30 days after bloom when the crop is half of its final weight, and we will clean pick parts of the vineyard with a machine, weigh that fruit, double the weight of the fruit, and that's what our estimate is at the end. So we kind of throw out how many shoots per vine, clusters per shoot, and berries per cluster, right? And that all just goes into the pick.
Yeah, you do what we call a destructive sample, which
Correct.
well, some growers don't like to do, but if you have a small vineyard, every vine counts. But you're doing what, 1% of the block or something?
Yes.
You actually harvest at
It's
30 days after bloom. So tiny green berries, right?
yes. So each sample is the sample size is 1% of an acre, but how many that you'll do in an acre is part of the question we're trying to answer. So with these sensors, we're trying to identify what the spatial pattern is in the vineyard, right? So to me, it's, the old saying, it's not the size of the dog in the fight, it's the fight in the dog that matters. Yeah. So same thing with variation. It's not really about the size of the vineyard. It's about how much variation is in that vineyard. So like we could have a 1 acre, 2 acre, 3 acre block here in New York that has a high amount of variation based on how much our soils change. I mean, our soils are based on ancient beach ridges off of Lake Erie. So like every 20, 30 feet, the soil can change
Yeah.
versus, a 640 acres in a plot in Central California, which can be very uniform
Yeah.
based on the soils that are there.
Yeah.
So we try to identify using sensors what we call the spatially structured variation in a field. So there's an amount of variation in the field that's random or what we call stochastic, right? It's big vine, small vine, big vine, small vine next to each
Stochastic.
other.
I'm gonna add that to my vocab immediately.
Yeah.
Find some intelligent way to use that at the next
But
line
when you hang out with data scientists, they start using words like that. And I call it randomness, right? There's a certain amount of vine to vine variation
Yeah.
that isn't spatially structured. And then what we try to tease out of the data is what's spatially structured, right? If I have a zone over here, I may have big and small vines, but more vines are big. And on the other end, there's big and small vines and more vines are small. So that means something to me viticulturally that I would actually manage those two zones differently. And that's what we're trying to draw out of the data.
So we've gotten to the point where you've reduced the number of data points we need to take, but how do we get there? You're talking about using these proximal sensing tools, and maybe someday it'll get to the point where we can do it with satellite when that imagery gets better. Maybe we're almost there. So what are you doing and how's that work?
So the easiest thing to do, and probably the most direct thing that we do, is we use an NDVI sensor. And so NDVI is the reflectance of healthy green leaves, and you're just measuring that reflectance. And you can do that from the ground. You can have a sensor mounted to a farm vehicle, a tractor, pointing at the sidewall of the canopy, and you'll get an NDVI signal. You can do it from a drone, you can do it from an airplane, you can do it from a satellite. I particularly like being up close and personal with my vines. So for example, if you take NDVI from a satellite imagery, you're getting what we call a mixed pixel result, because you're getting what is being reflected off of the grapevine canopies, but you're also getting what's reflected off of what's growing in between the vines in your row center. Which is a big problem for us in New York, because for most of the season it's green. The row centers are green. So
that's right. You have grass or cover crop growing there, and that picks up on this NDVI reading. Now, maybe you should also explain what NDVI means for the grower who hasn't gotten that far yet.
Okay, so it's normalized difference vegetative index. And so in the bottom line, what it's doing is it is telling you if there's a photosynthetically active tissue there. And so chlorophyll will reflect light, and we're measuring it. So our sensor has 3 wavebands. It does red edge, and near infrared wavebands. And we use 2 of those wavebands, the red and the near infrared, in some ratio called NDVI. So it's a vegetative indice. But using all 3 wavebands, you can calculate like 30 different vegetative indices. NDVI just happens to be the most popular one that everybody uses, but there's NDRE, there's plant cell health, there's a bunch of different ones. Part of the research we do is to try to figure out which one's the best one to use.
Again, efficiency, reducing not only the number of data points, but getting them at the place that counts, and being able to show someone who's not an expert exactly where to go. But you do need to have these proximal sensors run through the vineyard in order to do this. What is going to be our solution for growers who don't have the equipment or don't have it nearby to hire? Is there something they can do on their cell phone? Is there something they can do visually to create a similar kind of?
Sure. Again, in the Efficient Vineyard platform. So just go to efficientvineyard.com, and then there's a bunch of information on there on how to get started. One of the tools that we have in the platform is what we call a data collector. So again, very customizable. Anything that you want to scout in the vineyard for, you set up a data collector on your cell phone. You just walk through the vineyard with your cell phone, collecting that data. Like I have a video on there talking about late season potassium deficiency, rating it visually. I didn't have a sensor. I had my cell phone, and I just walked through the vineyard rating potassium deficiency on a 0 to 3 level, and just walked through the vineyard. Took me like an hour to go through a 5-acre block. and collected that spatial data and mapped it. And then I could see the spatial pattern, and then I could use that to do my variable rate fertilizer management the next year.
Okay, that's pretty awesome.
Yeah.
So this is a zero cost tool, correct?
Yes.
I love. Thank you for doing that and staying with the university system, continuing to develop these things for the growers who are not, out there farming thousands of acres. So growers, let's just dig into that a little bit more before we go, Terry. You've told us where we can find it. What would we use it for in terms of crop estimation specifically? I know you've mentioned getting the data on, reducing your sample size potentially and zoning in on the proper areas. How does that relate to crop estimation if they're using the Efficient Vineyard app? And I think it's called My EV app. Is that the name of it?
Yep. Yeah. So you go, yes. Yeah. We really have built it and meant it to be a tool, and we've got a lot of grower input into building it. So that's been it. It just makes it very user friendly for viticulturists.
Yeah.
It's to lower the barrier to adoption for getting into using spatial data, and then graduating into using sensors. And then, you could even go farther and start buying up ag leader or Trimble systems that do even a lot more. But if you're just low cost, I want to get started, be able to use this, you can go on without a sensor, build a data collector. You could do all of your yield components, do a shoot count, a cluster count, a berries per cluster. You could do all of that stuff. Collect that spatial data, map it, visualize it, integrate it, which is my big thing, is integrating different spatial data layers to come up with better management decisions.